Algebra 1, Section 11.3, solving radical equations. Quick direction here, and then again, several examples. To solve a radical equation, get the radical by itself and power both sides. Okay. Now I'm looking at my plan that I made when we first got this textbook, and I've edited over time. And I used to say square both sides. To solve a radical equation, get the radical by itself and square both sides. And that's what's going to work for us here. But the full story is that a radical could be a cube root or a fourth root or whatever. So to undo that, a cube root, we would have to cube. Now, for the purposes of this lesson, it's going to be squared, but just keep that in mind because you'll all be Algebra 2 students next year, and that's what you'll have to do. Okay, so again, several examples. We'll get to that. And this says to solve and to check your answers. Now, you may have seen on my notes there, I forgot to mention it, we really need to check each answer here. I'm not really into checking as far as you showing me that you checked it, but you do need to check it. So when you get your answer, check and see if it actually works in the original equation. Okay, I will model that for you here several times. Okay, so it says to solve here. And I don't know why the repeat, but basically ask yourself what's happening to the variable and then undo things in reverse order. Our variable is being square rooted and then subtracted by 5. So if I would add 5 to both sides, you'll have the square root of x is equal to 4 plus 5, which is 9. Okay, now what's the undo operation for square root? Of course, is squared. So what we will do to both sides is to just take the power of 2 to both sides, and then that's going to produce our answer. Now, anytime we do this, someone is going to mistakenly think that there's going to be a plus or minus. Okay. Now, normally we forget to do the plus or minus in the appropriate spot, but there's also the opposite mistake, which is to put one in when it doesn't belong. Okay. It's when you square root both sides, different concept, different chapter. It's when you square root both sides that you do get a plus or minus in this situation. When you square it, you're still going to get one solution. So 9 squared is 81. Think of it this way. Is there any other number? Forget about the squared now. Just back to this problem right here. Square root of x equals 9. Is there any other number besides 81 that you could put in here that would make this true? Only 81 works there. And yes, I am going to check it. So I believe that 81 is the answer because the square root of 81 minus 5 equals 4. I'm kind of wondering if that's true. And 9 minus 5 is 4. It checks. I know that 81 is the answer. Now notice in this one that the square root is just over the x. On the next one, the square root is over the x minus 5. Okay, so again, ask yourself what's happening to the variable and then undo things in reverse order. It's going to go a little different here than it did on the last one because my variable is being subtracted by 5 and then being square rooted. On the last problem, it was the other way around. So right now, I'm going to go ahead and square things. And this would be x minus 5 is equal to 4 squared, which is 16. And then you should add 5 to both sides, and your answer, you think, is 21. Go ahead and check that. Now, you want to check it into the original problem, not after you've squared it, right? This is where the extraneous solution, by the way, that's what it's called. If you have a solution that doesn't actually check, it's called an extraneous solution. That's where the extraneous solution can come about. So where do I want to check? I want to check the square root of 21 minus 5, wondering if that's equal to 4. Well, 21 minus 5 is 16. The square root of that is 4. 4 equals 4. It checks. We know that 21 is the solution. Here's a fun one. On a roller coaster ride, your speed in a loop depends on the height of the hill you have just come down and the radius of the loop in feet. I'm glad that there are engineers that figure this kind of thing out before they send you out on a roller coaster. The equation, I'm glad that the hill's high enough to get me through the loop. Amen. The equation v equals 8 times the square root of h minus 2r gives the velocity v in feet per second of a car at the top of the loop. 8 root h minus 2r. Okay, and it says the loop on a roller coaster ride has a radius of 18 feet. Your car has a velocity of 120 feet per second at the top of the loop. How high is the hill? Okay, so we'll be solving this for h, given that we've been given the other two values. The velocity is 120. H we don't know. The radius of the loop is 18. Solve this for h. Okay, well, again, ask yourself what's happening to the variable and then undo things in reverse order. H minus 36. The first thing that's happening to H is being subtracted by 36. Then it's having the square root taken of it. And then finally, it's being multiplied by 8. So I'm going to undo things in reverse order. And I'm going to divide both sides by 8. You see, if you divide the right side there by 8, since it's a multiplication, 8 is multiplying this, the 8s will just cancel. And 120 divided by 8 is 15. I will go ahead and simplify negative 2 times 18 is negative 36. When I square both sides, I'll get 225. And now the square root is gone. You've squared the both sides. These two undo each other. 15 squared is 225. And this is just h minus 36. And I'll bring my work up to here. You should add 36 to both sides. So h is going to be equal to 261. That's the height of the hill, 261 feet. Okay, moving on. Another equation. By the way, back here, if you were here, we talk about all the roller coasters that I've ridden in my life. I've done many. Everything at Cedar Point, everything at Great America, everything at Universal Studios, at least the way it was 8 or 9 or 10 years ago. Everything at Adventure Island, everything at Disney. I'm a thrill seeker. Anyway, back to the boring stuff. When the radical is on both sides, you're already ready to go, right? I said get the radical. At the beginning, we said get the radical by itself and then power both sides. Well, in this case, there's only radicals. They're on each side of the equation, so we're just going to go ahead and power them right now. Square both sides. And you'd be left with just 3x minus 4 is equal to 2x plus 3. And I would subtract 2x from both sides. And then I would add 4 to both sides, and you get x equals 7. Now we should check that back into the original, right? Don't check it here. 7, if you've done this math right, 7 will for sure work here. We don't know if it's going to work in the radical equation. So check it here. Square root of 3 times 7 minus 4, wondering if that's equal to the square root of 2 times 7 plus 3. Okay, well, 3 times 7 is 21, minus 4 would be 17. This is the square root of 17, whatever that is. And over on this side, 14 plus 3 is 17. You got the square root of 17 equals the square root of 17. That means x equals 7 is the solution. Now, I will note that we didn't check the roller coaster problem. It works, and it was the only number that could work anyway. So if there's going to be a roller coaster that exists, it's going to have that height of the hill based on the formula they gave us. All right. Now, you might ask at this point, why am I making this big deal about checking your solutions? Well, watch what happens here. I think this is where the fun actually begins. Yes, the radical is by itself, so we are ready to square both sides. And this is x squared. And this on the right is now just the expression x plus 12, right? The squared and the square root have undone each other. And now you have this. Now, think back to chapter 10. What would we do with this? You should get everything by itself. So I would subtract x from both sides and subtract 12 from both sides to make the right side 0. If you decided to subtract x squared from both sides, that would still work. That's going to make factoring harder, though. If you're going to subtract x squared from both sides to make this 0 equals negative x squared plus x plus 12, you're probably going to have to use the quadratic formula, whereas the way I do it, keeping the lead coefficient positive, it's going to be factorable. And in the homework, I can just give you this hint. Problems like this will almost always, if not always, be factorable. So x and x. How about 3 and 4 to multiply to give you 12? They are different by 1, different because of this expression. Actually, we want a negative here, so the bigger number should be negative. And there we go. Now, moving forward, in chapter 10, we also learned about the zero product property. Here you have x plus 3 and x minus 4 multiplying to give you 0. That means either x plus 3 is equal to 0 or x minus 4 is equal to 0. Solving this, you'll get x equals negative 3. Solving this, you'll get x equals 4. We need to check both solutions. I think it's rather funny, a little bit funny, that on the early problems, when I knew the solutions were going to be solutions, they made the point to say, check your solutions. And then here we get to the one where it actually matters, and they left that direction off. They didn't make that mistake in the book. It's going to say, check your solutions, and you should really check every solution in this whole section. Because look, back in the original problem, if I plug in -3 in for x is equal to the square root of -3 plus 12, I'm sorry, -3 squared. No, not -3 squared. -3 is equal to the square root of -3, yeah, plus 12, sorry. What's going to happen on the right? -3 plus 12 is 9, the square root of that is going to be 3. -3 is equal to 3 is not true. So what we thought was a solution, x equals -3, is actually not a solution. Now let me just be really clear. Let me just make sure you're picking up every little detail here. -3 is a solution to all of these equations. It is. It's a solution to the quadratic. If you graphed this quadratic right here, it would cross the x-axis at -3 and +4. But -3 is not a solution here, meaning that when we squared both sides, we created an extra solution that really isn't there, right? Because -3 doesn't work into this. Now, 4 will work. 4 is equal to the square root of 4 plus 12 is the same as saying 4 plus 12 is 16. The square root of that is 4. That one checks. This is your solution. If this were a quiz or a test, for full credit, I would expect to see, I don't really expect to see this work right here. That's kind of up to you. But what I would expect to see is both solutions, like both possible solutions, and then a circle around the one that's correct and an X around the one that's incorrect, or maybe a label that says extraneous and a circle around the one that is correct. Okay, so just 4 in this case. Only 4 was the solution. All right, one more. Square root of 3x plus 8 equals 2. I would subtract 8 from both sides first. The square root of 3x then would be equal to -6. Now, let me pause on something. Is there any way this is true? Is there any way you're going to square root something and it's going to come up with -6? You know what? I really could have asked this question back here. Is there any way in this check right here that we're going to do a square root and come out with a -3? No. So really, did I even have to go through this step? Not really. If you can recognize that this square root representing the whole right side of this equation, it's never going to come out to negative. You square root something, it's going to be either positive or 0, never negative. And that's what's going on with this problem too. Whatever x is, when it gets multiplied by 3 and then square rooted, it's not going to come out to -6. Because if the radicand ends up being negative, we're square rooting a negative, and that's actually an imaginary number, something we'll teach you about in Algebra 2. If it's 0 or positive, it's not going to be negative after you square root it. So you can stop right here if you can see it and say no solution. Now you might say, well, I don't think I'm going to remember to get that. I'm not going to catch that at this spot. Okay, no problem, but you need to check your answers. Because if you continue with the problem and you square both sides, and this would be 3x, and this would be positive 36, right? All of -6 squared is positive 36. And when you divide by 3, you'll get 12. You need to check the 12 because the square root of 3 times 12 plus 8 equals 2, wondering if they're equal, would be, this is 36, square root is 6. 6 plus 8 is equal to 2. Is 14 equal to 2? No. Okay, so we thought we had a solution. We thought it was 12. We thought we had one solution. We thought it was 12. That's extraneous. And if we thought we had one solution and it turned out to be extraneous, what do we say? No solution. And that is it. Thanks for tuning in.